Is on Virginia's SHRP2 R06A project, NDT for bridge decks. And our next young man, the presenter, is a man that needs no introduction.
All right, good afternoon, everybody. Again, I'd like to tell you just a little bit about Virginia's SHRP2 R06A project. This presentation will provide an overview of Virginia's work under the SHRP2 R06A program. So what is SHRP2? If you haven't heard of it, it is the second strategic highway research program. It was a national partnership sponsored by FHWA, AASHTO, and TRB. SHRP2 was created to find strategic solutions to three national transportation challenges: improving highway safety, reducing congestion, and improving methods for renewing roads and bridges. SHRP2 renewal research filled gaps in research and development to produce user-friendly tools so that innovative design and construction methods can be applied more broadly. It tested and objectively evaluated alternate methods to provide transportation agencies with information they needed to deliver projects faster. Renewal research projects simplified access to information on successful practices in performance specs, utilities, interaction with railroads, and other. Okay, so what is the R06A part of this? The R06A was non-destructive testing to identify concrete bridge deck deterioration. So the R06A was a sub-project, if you will, of SHRP2. And again, it identifies non-destructive testing technologies for detecting deterioration in concrete bridge decks. The first phase created a report documenting and validating promising technologies, and the report graded and ranked the technologies based on results of the validations, and that report is available online. In addition, SHRP2 Implementation Assistance Program was launched in 2013, and through 7 rounds of SHRP2 provided more than $130 million in financial support and technical assistance to transportation agencies across the country. Virginia is involved in 3 of these initiatives, or has been involved: the non-destructive testing for concrete bridge decks, R06A, service life design for bridges, R19A, and non-destructive testing for tunnel linings, R06G. There's also a lead adopter incentive available to help offset the cost associated with product implementation and risk mitigation, and Virginia was a lead adopter in the R06A program. Virginia received a $100,000 grant under the Round 4 Implementation Assistance Program, and we are utilizing, or have been utilizing, this grant to apply NDT technology for the assessment of a series of concrete bridge decks. We're implementing the technology in 2 ways: rapid screening of deck condition for many structures, aka network level analysis, to assess conditions, help with prioritization and planning, and then development of detailed damage quantities on individual bridges. We develop contracts as part of our grant obligation. We develop contracts for non-destructive testing technologies for bridge decks, and these technologies included infrared thermography and ground penetrating radar. 2 different rounds of contracts were advertised. The contracts documents contained qualification requirements for the firms performing the work. The firms had to have a minimum of 5 years experience in performing the services requested. They had to have, the project managers had to have a minimum of 5 years experience, and we required the submission of resumes for all of the project managers. The first contract included both infrared and ground penetrating radar. The contract was awarded to 1 contractor in February of 2017. The unit prices for this work were much lower than I had expected they would be. They were about 8 cents a square foot for both the infrared technology and the ground penetrating radar technology, and then we also had costs for traffic control and mobilization. This first contract included 6 bridge decks, totaling a little over 76,000 square feet. The second contract was advertised to include 2 lots, 1 lot for infrared thermography and 1 lot for ground penetrating radar. Choice of technology would be based on the bids that we received. Based on the bids that we received, the lots were awarded to separate contractors. Lot 1 was infrared thermography. This contract was awarded in September of 2017. Deck area scan was almost 252,000 square feet for 19 bridges. The contract total was about $18,000. prices for the infrared scans was 6 cents a square foot, again with some costs for traffic control and mobilization. Lot 2 was for ground penetrating radar. This contract was awarded again in September of 2017. It was the same bridges. The bid cost was 6.5 cents a square foot, again with traffic control and mobilization. Implementing this technology for infrared. Lot 1, which was the infrared, we had requirements, technical requirements in the contract that the work be performed in accordance with ASTM D4788, using a host vehicle that was capable of collecting real-time data at or near highway speeds, which we defined as 45 miles an hour. We required that the host vehicle be equipped with a high-resolution thermal camera, and that the host vehicle be equipped with a high-resolution video camera. The test data was to be analyzed for the defect features in the deck. The defect features were defined as anomalous regions, spalling, previous patching, delaminated and deteriorated concrete occurring at the top layer of the reinforcing steel. And the results of the testing were to be presented in a written report that included a plan view showing areas and quantities for each of the defect features. The technology used was the deck top scanning system, which is a mobile platform that can be loaded and mounted onto a vehicle. It consists of an infrared camera, 2 line scanning cameras, a GPS unit, a speedometer unit that combine located surface and subsurface defects in the bridge decks. This is just an example of one of the mappings from the infrared technology, and this is an example of one of the high-resolution photographs showing previous patches in the deck. GPR, again, the contract documents had certain technical requirements. The work could be performed in accordance with ASTM 6087, and again, capable of collecting data at highway speeds, which we defined again at 45 miles an hour. The host vehicle was to be equipped with a multi-channel array of air-coupled, non-contacting horn antennas, or a multi-channel array of ground-coupled antennas. We gave the choice. It should have a center frequency of 1 gigahertz, with 1.5 to 3 preferred. And again, the host vehicle was to be capable of collecting high-resolution photographs at highway speed. Again, the test data was to be analyzed for defect features in the deck, required a written report, and required plan views showing the defects. This is a photograph of the unit that was used. Technology was a dual 2 gigahertz horn antenna that was manufactured by GSSI of New Hampshire. The survey vehicle was equipped with an electronic distance measuring instrument mounted to the rear wheel of the survey van, providing continuous distance data as the GPR data was collected. The data collected was recorded as controlled by the SHRP2 GPR system operated from within the survey vehicle. This is just a graph showing I guess you'd call it the raw data from the GPR scan. And then this is one of the maps that provided information about the quality of the concrete. You can say we go from green to red with crosshatch showing patching areas. Also, we required cover depths for the reinforcing steel as part of the GPR scan. So then this is just the results of how some of the data was presented to us. This is the infrared data. It was reduced to quantities shown by the AASHTO element condition states. Chart showing some of the GPR data. And then as a part of this analysis, we also looked at the element level inspection data and tried to compare that to some of the testing results. Next phase of the work will include a Virginia Transportation Research Council project to compare the reliability of the 2 rapid scanning techniques, that is GPR and infrared, and time-lapsed infrared in detecting deterioration of concrete bridge decks, and to form recommendations for maintenance actions from these evaluations. The tasks that will be included in this Virginia project: conduct a brief survey from other states on their experience with GPR and infrared, perform time-lapse infrared on 2 bridge decks with known history of performance from various evaluation methods, collect ground truth information from the pool of 25 bridge decks that were scanned under the previously described contracts, estimate the reliability of these non-destructive evaluation methods, and then form guidelines on subsequent maintenance actions. At the end of the day, we would like to develop a statewide contract for the evaluation of bridges in Virginia, which would include GPR, infrared, probably impact echo, half-cell readings, sounding, a wide variety of testing data that we could make the testing available to our district bridge sections so that we would have a contract mechanism to collect the data that was needed. And I thank you for your time and attention. Any questions? Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.